Section 9.5 and 9.6 I'm actually going to teach together. It's all about the graphs of quadratic functions. Alright, so in this section we're getting back to some of the graphical things, but pretty much all we looked at up until now was, for the most part, graphing of equations of lines. So now we're going to look at some of these equations that are quadratics, in other words have an x squared term in them, and we'll see that when you graph a quadratic it forms a smooth curve, which we call a parabola. So I guess the only thing that is required in order for it to be a quadratic is it has to have this ax squared term. Okay, a is just whatever number's in front of the x squared term. We call b whatever number's in front of the x term, and c the constant number that's on the end of the equation. So either way, we might get a parabola, smooth curve that may open upward or open downward, and we're going to look at different parts of the equation and how they affect the way the graph looks. So the first aspect we're going to look at is the a value, the number that's attached to the x squared, the coefficient of that x squared term. So the sign of the a value determines the direction of the opening, whether it opens up or opens down. And how that ends up working is if you have a positive a value, then your parabola, the curve, opens up. So it looks like a U. Okay. Whereas if you have a negative a value, it opens down. You see here we have a positive x squared, our parabola is opening upward. Negative 2x squared, our parabola opens downward, an upside down U. So positive opens up, negative equals the parabola opens down. Okay. So that's the first aspect we need to take into consideration, that a value. Okay, the number attached to x squared. Maybe we should actually write that in here. Technically, what is the a value here when there is no number written in front of x squared? Technically, it's an a value of 1. Okay, so that's why our parabola opens up in that example. Whereas in our bottom example, we have an a value of negative 2. And that is why our parabola opens down. In other words, flips upside down. Okay. So next aspect of the equation we're going to look at is this doesn't really have to do with the equation in this form that we have it written, but another part of the graph is that we call the highest or lowest point on the parabola, we call this the vertex. A vertex could be a maximum point if it's the highest point on the graph, or we might call it a minimum point if it's the lowest point on the graph. So looking at our two different graphs here, our first graph here, that is the equation x squared minus 8x plus 18, it has a vertex right here, the lowest point on the graph, that point, the ordered pair 4, 2. That would be a minimum because it is the lowest point on that U-shaped curve. Okay. So the vertex we'd say is the ordered pair 4, 2, since it's 4 units to the right and up 2 from the origin. Okay. Whereas our bottom graph, the upside down U-shaped graph, that has a vertex of negative 1, 2, 3, and then down 3 as well. So it has a vertex with the ordered pair negative 3, negative 3. Okay. So a vertex could be the highest point on the parabola, like in this case when it's opening downward, that is the highest point, we call that a maximum. Whereas when the parabola opens upward, the vertex is a minimum because it's the lowest point on the curve. Okay. Now another aspect of the graph is that all parabolas, all quadratic equations, they're going to produce these parabolas that are symmetric to a vertical line that cuts through that vertex. Okay, that cuts through that maximum or minimum point. So if we were to look at our graphs and draw an imaginary vertical line down through the vertex, you can see here how the graph is kind of a mere reflection symmetric on the left side of that vertical line and on the right side of that vertical line. We call that vertical line an axis of symmetry. And actually we typically give the equation for that line, and because every vertical line, their equations are of the form x equals some number. Every time we have a axis of symmetry, it's going to have an equation in that form. So x equals, well, the vertex had an x value of -3. This axis of symmetry would be the line x equals -3. Looking at our top graph, if we were to draw a vertical line cutting through that vertex, again you see here it looks like the graph is a kind of mirror image on the left side and right side of that axis of symmetry. And that has a axis of symmetry with equation x equals, well, here our vertex, it has order pair 4, 2. The x coordinate is 4. So x equals 4 is the line of symmetry. That's the equation for the line of symmetry. Okay. I think that's really all as far as these graphs we need to know, although the a value, that number that is out in front of the x squared term, the coefficient, it also determines how wide your graph is compared to the what we call the parent function, which is just the basic equation y equals x squared. So how we determine this is that if we have an a value, we actually say the absolute value, because it doesn't matter if it's positive or negative. If you just look at the number part of it, not considering whether it's positive or negative, if we just consider the number, if that is less than 1, okay, so like a fraction in other words, or a decimal, that makes the graph wider than the graph of just if we were to graph the equation y equals x squared. But if we have an a value, the number attached to x squared, if it is a number that's greater than 1, okay, well then that's going to make the graph become thinner than the graph of the equation y equals x squared. Any graph that has just a basic x squared without a number written out front is going to be the same width as the equation y equals x squared. So kind of comparing that back to our two graphs we just looked at, this graph right here, y equals x squared, well, it has the same coefficient, it has a 1 technically. This would be a y equals 1x squared as well. This would be the same, this graph is just as wide as this graph would be, y equals x squared. But look at our other graph, which had a -2 as its a value. Okay? We ignore the fact that it's negative, that's why we have absolute value of a. So just considering the 2, well, 2 is a number that's bigger than 1. 2 is greater than 1, so that's why our graph was thinner. See how this parabola here is like a thinner shaped upside down u than this u is up here. Okay? And if we had something like, we're here, I'll just give you an example, y equals 1/2 x squared. Okay, where our a value is less than 1, that would have produced a graph that's even wider. So you would have had a U shape that, come up here that was wider to the left and right than this U. Okay. All right. We're next going to look, I guess what we first looked at, these equations were what's called standard form, the ax squared plus bx plus c. Okay, this form right here, this form right here. We also are sometimes given parabolas or quadratics in what we call vertex form. Okay. Sorry, I'm kind of jumping ahead here. We're still going to look at them in standard form, but we're going to use what we call the vertex formula, which is a formula that allows us to find the vertex just from looking at the equation. Okay. So if we don't know what the graph looks like, and we're just looking at the equation and want to determine what the graph looks like, and it's in standard form, we can use this vertex formula. Okay. So vertex formula tells us that the x-coordinate of any quadratic in the form ax squared plus bx plus c, well, the x-coordinate of that vertex is going to be negative b over 2a. Okay. So looking at our equation, we have a function f of x equals 3x squared plus 12x plus 13. Before we look at the vertex, we first of all can talk about some of the things we discussed up top here. Our a value in this equation is 3. Okay. So that tells us a couple things. The direction that the parabola is going to open, because it's a positive, so we know the parabola is going to open upward. And also, is that going to be thinner or wider than, I guess, the graph of y equals x squared? Well, it's going to end up being thinner. Okay. Okay. Just because based on this, our a value, the absolute value of 3 is still 3. That's greater than 1. It's going to make it thinner. Okay. So we know it's going to be a little thinner than this graph we looked at up here. And also we know that it's going to open upward, just like that graph did up there. Alright, some other things now that we want to find. The vertex is a great spot to start. Okay, when we graph things, typically we want to plot the vertex and at least 2 other points. So that's what we're going to look at right now. So plot the vertex. And 2 more points. So we're going to use this vertex formula that we just introduced here. So to find the x-coordinate of the vertex, we do negative b over 2a. Okay, so the x value equals negative b over 2a. So substituting those values in, remember our a value is 3, our b value here is 12, our c value is 13. So negative b will give us a negative 12 in this case, over 2 times our a value, which is 3. So we're going to have negative 12 over 6, which gives us negative 2. Okay. So that tells us half of our vertex. We have half of the ordered pair. In order to find the rest of the ordered pair, the y value, we then have to plug in negative 2 into the function for x. And whatever our output is, that gives us the y value then. Okay. So for the vertex y value, we evaluate the f function at negative 2. Since we know the x value is negative 2. So plugging in negative 2, we have 3 times negative 2 squared plus 12 times negative 2 plus 13. Okay. You can do all that right on the calculator and put it in. Your calculator is just exactly how I put it here. Make sure to put parentheses around the negative values. And if you evaluate that correctly, you should get a positive 1. Okay. So now we know the complete ordered pair for our vertex. The ordered pair, negative 2 for the x value, 1 for the y value. Okay. So to start, we can go ahead over here, negative 2, 1, and plot ourselves our vertex. Okay. So I'm just going to go ahead and label it. Negative 2, 1. So now what we need to do is find 2 more points. And how typically, I guess a good approach to do this would be to make an XY table. Okay, table of values. So when we're considering our x and y values, we already know the one ordered pair, -2, 1. We found that as the vertex. But also, because we know all parabolas have an axis of symmetry, we know there's this imaginary line kind of cutting through that vertex. Okay, imaginary vertical line. So I can label that as well. Axis of symmetry. And the equation for that would be the line x equals -2, since the x coordinate of our vertex is -2. Alright, so we know our parabola opens upward. We knew that because the a value is 3. We know there's the vertex, so we're going to have some U-shape opening upward. But if we find one point to the right, we can kind of reflect it over this axis of symmetry, and then we would know a point to the left. So usually what I do is if I have, -2 I know is my middle point because it's the vertex. I find one point to the right and one point to the left. So I could use -1 and maybe -3 as my x values and plug them in. Or you have a lot of options. So I'm going to do that because that's the only way it's going to fit on this graph. So in other words, what I'm saying is we know the ordered pair -2, 1 is on our graph. So we want another point to the left and to the right of that. So we want to check when x is -3, what's our y value? And when x is -1, what is our y value? And then plot those 2 points. Okay. So let's go ahead and do that. To find what the y value is when x is -3, we evaluate the function at -3. So f of -3. So now plugging in -3 into the function, we have 3 times -3 squared plus 12 times -3 plus 13. Okay. Once again, you could do that all straight on the calculator, type it in just like that, and you'd get a 4. Okay. Which tells us we have the ordered pair -3 was our x value, and our output was 4. So we have the ordered pair -3, 4. Okay. So I can go over here to -3, 4, plot that point. Now because we have an axis of symmetry, I know I can pretty much just take this point and reflect it over that line, which means I should have -1, 4 as an ordered pair as well. You might want to, for this one, let's at least work through the math to confirm that, but you'll see that is the case. So we have -3, 4 there. So now we want to find when x is -1, what is y? So we want to evaluate f of -1. So putting it back in our function, just like we had here, instead of replacing the x's with -3, we're replacing them with -1. So 3 times -1 squared plus 12 times -1 plus 13. Doing that will also give you 4 if you put in your calculator correctly. Okay. So that gives us the ordered pair when x is -1, y is 4. So we do indeed have the ordered pair -1, 4 right there. So now we have our 3 ordered pairs, our vertex, and then 2 points on the side of each of those. The last step in drawing the graph then is just to draw a smooth curve through them. Okay. Give a nice U shape to the graph. You don't want to draw it like a V. Okay, it doesn't produce a graph that looks like a V. It's more a U-shaped curve. If you remember earlier in the year we looked at absolute value equations, the equations that have the double bar in them. That actually produces a graph that looks like a V. Parabolas with the x squared equations, those always quadratics with the x squareds always have a U-shaped curve. Alright, so that's pretty much how we graph equations when they're given to us in the ax squared plus bx plus c form. We use a vertex formula to find the vertex, and then find a point or two on each side of the vertex, and then make our U-shaped curves. So as long as we have 3 points, it pretty much makes a good parabola. If we have 5 points, it makes it maybe a little better, but 3 is good enough. Okay. So I'm going to the next page. We're going to graph another parabola. And this one has the equation f of x equals negative x squared plus 6. So actually I'm going to slide it down a little so I can write some things above here. This one looks a little different. You notice there's no x term in the middle of this equation. There's an x squared term, and there's a constant term, the 6, but there's no middle term that has just an x in it. So we can talk about what our a, b, and c values are here. Our a value, which is the coefficient of x squared, that's a negative. Technically that means it's a -1 out in front. The b value, okay, the coefficient of the x term, because there's no x term in the equation, technically we have a b value of 0. And then the c value is always the constant value on the end of the equation. In this case it's a 6. Okay. So now that we know that, we can discuss some things. So our a value equals -1. What does that tell us about the equation? Well, we know, or what does it tell us about the graph? That tells us the way it opens. It's negative, so it opens down. So we're going to have an upside down shaped U. What does it tell us about the width also? Well, -1, if we took the absolute value, that would be +1. It'd just be the same kind of width as if we had x squared. So if you're asked that, you'd say it's the same width. Okay. Well, the same width as y equals x squared would be. So, using this formula, because this equation is again in standard form, we have to use the vertex formula to try to find where this parabola starts. Okay, and then we know where that parabola is starting, it opens downward from there. So let's find the vertex. Okay. Using that vertex formula, again, -b over 2a is going to give us the x-coordinate of the vertex. Well, in this case, that'd give us negative. Remember, our b value was 0. So -0, which really would just be 0, it doesn't matter what that's over, although 2 times a would give us 2 times -1. 0 divided by anything, 0 over anything is going to give us 0, okay, for our x-coordinate. So the x-coordinate is going to be 0. To find the y value of the vertex, okay, that's going to once again be the function f evaluated for that x value of 0. So plugging 0 into the equation, we have -0 squared plus 6, which is just going to be 0 plus 6, gives you 6. So that tells us when x is 0, y is 6. So our vertex, ordered pair, is going to be 0, 6. So 0, 6 on our graph would be that point right there on the y-axis. And this is actually going to be the case anytime you have an equation, a quadratic equation, that is missing that middle x term. Your vertex will lie somewhere right along the y-axis. Matter of fact, that number on the end, the 6, tells you exactly where it's going to fall. Okay, it's like finding the y-intercept. you put in 0 for x. If you remember when we were doing lines, we'd put in 0 for x, and whatever we get tells us our y-intercept. So in this case it's 6. So we know where the graph starts. We know because the a value is negative, it's a negative x squared, it's going to open downward. So we're going to have a downward shape u, with that being the highest point. Okay, that vertex of 0, 6. So let's find some more points now. Remember from here, what we do is make an xy table. Now this one I'm actually going to find 5 other points, just to give us a really good idea what the graph is going to look like. Okay. So I'm going to put in our vertex 0, 6, and that's kind of our middle point. I'm going to find 2 points to the left of that and 2 points to the right. So check -1 and +1. Okay, check those as x values, and then -2 and +2. Okay. First of all, though, we could talk about the axis of symmetry. Remember, that's always a vertical line cutting down through the vertex. Well, the axis of symmetry is actually going to be the y-axis. You see, if I cut a vertical line down through that vertex, it's going to be just the y-axis. Okay. So in this case, we would say our axis of symmetry is the line x equals 0. Because our x coordinate at the vertex is 0. In other words, it's the y-axis. Okay. So then let's find these other points. If I was going to check, when x is -2, to find the y value, we have to evaluate f of -2. So we plug -2 into our equation, and we have negative x squared, so it's going to be negative of, or opposite of -2 squared plus 6. Got to be careful here with the signs. -2 squared will give us 4, but then we have to make it negative, which will give us -4. So -4 plus 6 gives us a +2. Okay. So +2. So that tells us the ordered pair -2, 2 is on this graph. Okay. So -2, 2. Go ahead and plot that point. But remember, our graph is going to be a mirror image. So any point here, we could just kind of reflect over this line. So if we have -2, 2, and we reflect it over the axis of symmetry, we know we're going to have a point over here at +2, 2 as well. If we go ahead and evaluate that, let's evaluate f of 2 to find out, or to confirm that. So when x is 2, what is our y value? So plug in 2 into the f equation. So we have negative of +2 squared plus 6. +2 squared gives us 4, and then making that negative gives us -4 plus 6 once again, which gives us 2. So that confirms we do have the point 2, 2. Okay, when we plugged in 2 for x, we got an output of 2 for y. So we have the same point there on the left and on the right. Both when x is -2, our y value is 2, and when x is +2, the y value is 2. So now we can kind of do the same. You could really draw the graph right there, but just give a little bit better idea of the shape, check at -1 and +1. So when x is -1, if we want to find our y value, we evaluate the function f at -1. So we're going to have the opposite of -1 squared plus 6, which again is going to give us a -1 plus 6, which will give us 5. So that tells us we have the order pair -1x for a y value of 5. which is negative 1, 5. So at negative 1, our y value is 5, which would be right there. Which means at positive 1, it would also have to be 5 to make a mirror reflection over the y-axis there. So we can really see what this upside down u is kind of going to look like. But once again, just to confirm, if we plug 1 into the f function, we get negative of positive 1 squared plus 6 equals, well again, it's going to give us negative 1 plus the 6 will give us a positive 5. So when x is 1, y is positive 5 again, so it confirms we do get that point. So then the only thing left is to draw a smooth curve, in other words an upside down u through those points. Alright, and then we really have a good idea what that graph looks like. So at this point, we're now going to get away from the standard form which we were looking at things, and now we're going to look at what we call vertex form of a quadratic equation. So vertex form of a quadratic is going to be this form right here, where we have our a value is actually written out in front of a parenthesis, and then we have x minus plus or minus some number in the parenthesis, and the power of 2 where we have that x squared, the power of 2 will be outside of the parenthesis, and then might be plus or minus some number on the outside. Okay? So that's vertex form. So you see some examples down here of what vertex form looks like. Okay? The reason we call this vertex form is because this h value inside the parentheses with x and this k value out on the outside actually tell us the coordinates of the vertex, our x and our y value. So when you see it, it's almost as if it's just h and k. You kind of have to think it as opposite though for the h. Whatever the h value is inside of here in the side of the parentheses with x, we take the opposite sign, and that tells us whatever the h coordinate, the x coordinate is going to be. But then whatever the actual sign of k is, that tells us the actual y value for the vertex. So maybe write this in here. H is the x value, and k tells us the y value. Okay. So kind of that maybe sounds a little confusing. I'll show you how to apply it. It's really not that bad. So for our first two examples here, state the vertex of these equations. So we have parentheses x plus 8 squared plus 3. Y equals that. So this value inside here with x tells us what the x value of the vertex is going to be. But we want to take the opposite of this h value, okay, the value inside the parentheses. So not a positive 8, but a negative 8. Then here you want to take the actual k value. So the k value is the number on the end. We actually want to take that sign. Okay. So this tells us our vertex, the maximum or minimum point on the graph is going to be the ordered pair negative 8, comma, 3. And we actually also know whether the graph is going to open upward or open downward because there's no negative number out front. Okay, and there's no negative a value out front. So since it's technically a positive out front here, the vertex would be, we know this graph is going to open upward. It's going to be upward, a U shape, not an upside down U, but a regular U. Okay. We're looking at our next example. Okay. we actually have a -3 out front for an a value, and it works just like the a values we were talking about before. So since it's negative, this parabola would open downward. But we're not worrying about that right now, we're just worrying about the vertex. So now for this one, once again, we consider the opposite of the h value, so the opposite of that -5. But then we take the actual k value. Okay. So here, our vertex would be the ordered pair. Not -5, but +5. And the actual sign there, -6. So the number inside the parentheses with x tells you the x coordinate, although it's opposite. +8 made it -8. -5 made it +5. And then the number on the outside tells you the y value. But you actually take that actual sign. +3, +3, -6, a -6. So let's kind of take a look at this and see how we can graph parabolas when they're given to us in this form. Okay. So we have graph the equation y equals 4 parentheses x minus 6 squared plus 1. So we have, from this we can tell what our vertex is since we're given the equation in vertex form. Remember, the x-coordinate is going to be the opposite of the sign in there, so instead of -6, it'd be +6. And then the actual sign of that +1 there, so +1 for our y-coordinate. So right off the bat, we already know our we know our vertex. The ordered pair 6, 1. So 6, 1. Come here and draw in our vertex. Okay. And then next, all we really need are 2 ordered pairs, one on the left of that point and one to the right of that point. And we can draw in our u. It is a +4 out in front of the parenthesis, so it's a +4 a value, meaning our parabola is going to open upwards. It'll be an upward shaped u. In order to find a point to the left and to the right of that vertex, though, we can just go ahead and make a table, an xy table of values. Well, maybe we can do this first. We can draw in our axis of symmetry again. Okay. So that is the equation. Our x-coordinate of our vertex is 6. So our axis of symmetry has the equation x equals 6. Okay. And I guess we could draw it down as well. Make that point a little more bold. And now, looking at our looking at an xy table of points, let's just make 2 other points. We don't need 5 this time. 3 will be good enough. And we know our vertex is going to be in the middle, so the ordered pair 6, 1 we'll put kind of here in the middle, and we want a point to the left and a point to the right. So we can check an x value of 5, and to the right would be an x value of 7. Okay. So we can plug these x values into the equation just like we did before. So to find our y value, we can put our equation 4 parentheses, now place your x value, which is 5, minus 6 parentheses squared plus 1. Okay. So doing so, if we follow order of operations, you want to subtract inside the parenthesis first, and then multiply it by that 4 out front. So that's going to equal 4 times, subtracting 5 minus 6 would give you a -1, and then we'd have to square that plus the 1. Okay. Although once again, you could do all this, you could type it in just like that on your calculator, and it could handle that. That's going to give you 5. So when x is 5, y is 5. So this tells us we have the ordered pair 5, 5 on our parabola's curve. So we can go ahead here at x is 5, we go up to a y value of 5. Plot that point. Okay. So because all parabolas are symmetric to our x symmetry, we know when x is 7, we also have to have the ordered pair. We also have to have a y value of 5. We can confirm that. So let's plug 7 into our equation for x. So 4 parentheses 7 minus 6 parentheses squared plus 1. 7 minus 6 in the parentheses gives us 1. So we have 4 times 1 squared plus 1. That also is going to give us 5. Okay. So because of that, x is 7, y is 5. We again get the ordered pair 7, 5. Well, again, we get the y value 5. So to graph here, we just want to put a smooth curve through these 3 points. Alright, and there's our parabola. Now the last page of these notes is going to look at the x-intercepts of these quadratics, where the graph crosses the x-axis. And again, it's not 10.5, this is 9.5 and 9.6. Continued here. And in order to find the x-intercepts of these graphs, actually something that we've already been doing for quite a while in this class, a technique that we've been using for quite a while now. So let's first talk about x-values for our x-intercepts for a second. So if you think about along the x-axis here, okay, our x-axis is our horizontal axis, we always have y coordinates that are the exact same. Okay? For any graphs, the x-intercepts, the y value is always going to be 0. For example, this x-intercept right here, this might be the point 3, 0. This is to the left here, this might be the ordered pair negative 2, 0. They always have a y value of 0. So, because the x-intercepts are, in other words, they tell us which x value gives you a y value of 0. It's in other words, it's saying which x value makes our quadratic equal 0. So we can find our x-intercepts if we were given an equation. If we're given the equation for the graph, we can find our x-intercepts by solving the equation ax squared plus bx plus c, and we just set it equal to 0. Because this will tell us what x value will make the y value equal 0. And in other words, that's what finding an x-intercept is. An x-intercept is an x value that makes our y value, or in other words, a quadratic, equal 0. So how do we solve an equation when if it's set equal to 0? Well, if it involves an x squared, typically we factor. So let's look at some of our examples. You don't necessarily have to factor because we also now know how to use the quadratic formula to solve quadratic equations. So you have that choice. So our first example here, find the x-intercepts of f of x equals x squared plus 4x minus 5, and then graph. So solve this. In order to find our x-intercepts, we just take our quadratic equation, okay, x squared plus 4x minus 5, and we want to see what x values will make it equal 0, and that'll tell us our x-intercepts. So we set the equation equal to 0, and as I said, we have two choices. we can either factor or use the quadratic formula. Now the quadratic formula is nice because it will work on any x squared equation that you have. Factoring doesn't always work. There's some equations that can't be factored. However, factoring is a little easier if it is something that's possible to factor, and this is possible. Okay, so since this is an easy one to factor, let's use that method. So we have x squared plus 4x minus 5. We want to factor that left side of the equation. So two numbers that multiply to give us negative 5, that add to give us 4. Those numbers are going to be 5 and negative 1. Positive 5 and a negative 1. Okay, 5 times negative 1 gives you negative 5. 5 plus negative 1 gives you 4. So from that our two x value solutions would have to be a negative 5 to make that parenthesis equal 0, and positive 1 to make that parenthesis equal 0. So, because those are the two x solutions for that equation, that actually tells us our two x-intercepts. The ordered pair negative 5, 0, and the ordered pair 1, 0. So we can come over here on the graph, negative 5, 0, and 1, 0, and plot our ordered pairs. Okay. Then the only thing else we would have to do is use the vertex formula, because we're in the standard form. We're not in that parenthesed vertex form. We'd have to use the vertex formula to find the vertex to see how far up or down this graph goes. Because x squared is positive, we know there's going to be an upward opening parabola, so it's going to be a u. So use the vertex formula. X equals negative b over 2a. Okay. So in this case, what is that going to give us? Negative 4 over 2 times our a value is 1. So that gives us negative 2. Okay. And then if we actually plug negative 2 into the function, into the f function, just to kind of save some time, I'll tell you that it's going to give us a negative 9. So when x is negative 2, y equals negative 9. So it's going to be kind of off our graph here, but we're going to have the order pair negative 2, negative 9, 5, 6, 7, 8, 9. It's going to be all the way down here somewhere for our vertex. Okay. So we can draw our smooth curve through those 3 points. So again, vertex, negative 2, negative 9, and then 1, 0 as an x-intercept, negative 5, 0 as the other. Okay. Alright. And then the last little bit of this section is going to be using the discriminant, which we've already talked about, but it tells us how many x-intercepts we're going to have. Because remember, the discriminant would tell us what kind of solutions we had to this equation.